Welcome to section 5.1, day 3, simplifying trig functions. Today's objectives are to simplify by combining fractions and rewrite trig functions to eliminate fractions. So we want to simplify secant of x over 1 minus secant x minus secant x over 1 plus secant x. We want to combine our fractions. To do so, we must have a common denominator since we have a subtraction sign between. So our first fraction we must multiply by 1 plus secant x, both top and bottom. Our second one we must multiply by 1 minus secant x, both top and bottom. When we do this, on the numerator we're going to have secant x, 1 plus secant x, all over. When you multiply these together on the denominator, you're going to get 1 minus secant squared x. Do the same thing for the next one when you take secant times 1 minus secant. And I'm going to show you all the steps. We have secant x, 1 minus secant x, all over 1 minus secant squared x. We can do some manipulations. I'm going to multiply the secants in first on both of these. So we have secant x plus secant squared x over 1 minus secant squared x. We're going to subtract off secant x, and we have a negative secant squared x all over 1 minus secant squared x. Because we have to be careful when we combine our numerators. This is a minus sign against the whole numerator. So if it makes it easier, put this in parentheses. We have secant minus secant. That goes away. We have secant squared x minus a minus secant squared x. We have 2 secant squared x's over 1 minus secant squared x. The other day when we did Pythagorean identities, one of the identities we had was this one. 2 tangent squared x plus 1 equals secant squared x. If we rewrite this, we can get tangent squared x equals secant squared x minus 1. If we look at the secant squared parts, we have secant squared x minus 1 for tangent squared x, but we also have 1 minus secant squared x in our denominator. To get these the same, we're going to multiply what I'm doing up here in purple by negative 1. So we flip our signs so our signs match. Multiply both sides by negative, we get this, and when we rewrite this, we get 1 minus secant squared x. These are probably the trickiest parts of what we're doing. So we can replace, these are all equals by the way, as we go through. We can replace our denominator now with negative tangent squared x. So we have 2 secant squared x's over negative tangent squared x. This again gets a little trickier as we do these. And there's a couple of different ways to think about this. I'll go up here now. So division by tangent squared is the same as multiplying by its reciprocal. The reciprocal of tangent is cotangent. So we can change this to be 2 secant squared x times negative cotangent squared x. Because cotangent is the reciprocal of tangent, and division is the same as multiplying by a reciprocal. We can then change our secants and cotangents into sines and cosines. This is 2. This is 1 over cosine squared x. This is negative, we're multiplying here by the way, cosine squared x over sine squared x. And when you do this, the cosines are going to cancel out. We're going to be left with negative 2 over sine squared x. And 1 over sine squared is the same as cosecant. So we have negative 2 cosecant squared x's. And this is my simplified form. These can take a little bit of time because you have to do these manipulations. But we've got it down to one ratio, one trig function. We have negative 2 cosecant squared x. We cannot simplify it any further. If we do anything else, we're going to introduce some parentheses or some addition or subtraction into it. This is the simplest form we can make it. Here we have, simplify, 1 plus cosine x over sine x plus sine x over 1 plus cosine x. Again, to combine, the first thing we need to do is get common denominators. So multiply this by 1 plus cosine x. Both numerator and denominator, multiply this, the other side, by sine x, both numerator and denominator. I'm going to leave them separated right now. We have 1 plus cosine x times 1 plus cosine x. I will leave them separated for now. And this is all over sine x 1 plus cosine x. We're going to add sine x times sine x over sine x 1 plus cosine x. I will now multiply these together. So 1 plus cosine x times 1 plus cosine x. Remember doing binomials that are squared. The first term squared plus first and last terms multiplied together doubled. So we get 2 cosines of x. Cosine x times cosine x is cosine squared x. We have a plus here between, so I can just combine these into one numerator. And then in the denominator, we have sine of x, 1 plus cosine x. I am going to keep these separated right now. Then we look at our numerator. Is there anything we can do to simplify this? And there is. We can use one of our Pythagorean identities. We have a cosine squared and a sine squared. Added together, that means we have a 1 there. We can switch it out using our Pythagorean identity. So we have 1 plus 2 cosine x plus 1 all over sine x, 1 plus cosine x. We're going to keep simplifying the numerator. We can add the ones together. We get 2 plus 2 cosine x's all over sine of x, 1 plus cosine x. Then if we factor out, we want to get stuff we can cancel out or simplify. So if we factor out a 2 in our numerator, we get 1 plus cosine x. Then we have sine of x, 1 plus cosine x in the denominator. Now we can cancel out like terms between our numerator and denominator. The 1 plus cosine x is cancel. And we're left with 2 over sine of x. And if we have 2 over sine of x, 1 over sine of x is the same as cosecant. So we have 2 cosecant x. We have simplified this down to one trig function with no division in it, no adding or subtracting. And this is as simple as we can get it. 2 cosecant x. This is a process we go through. So now we have 1 plus tangent squared x over cosecant squared x. We want to rewrite this where there are not fractions. Well, if you go to your Pythagorean identities, 1 plus tangent squared x is the same as secant squared x. So we can switch that out right away. Now we have secant over cosecant squared. So the numerator becomes 1 over cosine squared x. The denominator becomes 1 over sine squared x. If we want to divide by a fraction, it's the same as multiplying by the reciprocal. This is 1 over cosine squared x times the reciprocal of our denominator, which is sine squared x. And when we combine these, we get sine squared x over cosine squared x. And sine over cosine is the same as tangent So we get tangent squared x. There are no fractions left. We are down to one term. We have simplified. All right, so now we have sine squared x is over 1 plus cosine x. We want to rewrite this so there's no fractions again. One of those that'll help get rid of our fraction is to do something with our denominator. And I'm going to multiply my denominator by its conjugate. If you guys remember what a conjugate is, we're going to multiply the bottom and the top, by that matter, by the conjugate of 1 plus cosine x. And that means we're going to multiply it by 1 minus cosine x. And if you understand what well, you'll hopefully see what I'm doing, why I'm doing this here rather quickly. I'm going to leave the numerator alone. I'm just going to rewrite it. But when you do the denominator and you do the conjugate, you're left with the first term squared, which is 1, minus the second term squared. And we've done this one already a few times using our Pythagorean identities, but I'll show it again up in the upper corner. If we want to get sine squared by itself, we subtract cosine squared from both sides. So we can replace 1 minus cosine squared x with sine squared x. So now we have sine squared x, 1 minus cosine x, all over sine squared x. Well, we can cancel out the sine squareds, leaving just 1 minus cosine x. As those cancel, we no longer have any fractions. We can't simplify this any further. Even though there are two terms, we can't simplify it further. And we get that we equal 1 minus cosine x. That is our most simplest form. All right, that is how we go about rewriting more complex expressions to get rid of fractions. So today we are just using the identities we've learned from the previous 2 days to help rewrite into more simpler forms our fractions that we are given. Please show your work, how you're rearranging these things, how you're manipulating them so I can see what you're doing. Thank you for watching and have a nice day.